Hello, I am Rachel Stratton, and I'm going to be talking to you about solar panels, the science behind them, and what we can do with them. So, looking at regions of Africa and India, there are people who have little to no access to electricity and therefore sources of light at night. So, to get electricity to these people, we can look at solar panels, and a specific type of solar panel that we can think of it as is a dye-sensitized solar cell, which I would be calling solar cells. They can provide electricity that is more cost efficient, will improve these people's lives, and create a medium for missionaries in the future. So as of 2016, globally, there was 940 million people that had no access to electricity. That's almost 1 billion people globally. So using a type of solar panel could provide a clean and cheap energy source for these people to improve their lives. So looking at the solar cells, they are able to convert solar energy into electricity in similar fashion to photosynthesis in plants, and utilizing some fun properties of electrons. So looking at a diagram of the solar cell, there is an electrolyte solution sandwiched between two pieces of glass, and they're called FGO glass because they're coated with a special titanium oxide coating, which conducts electricity. So on each side there is a dye and carbon layer. The dye is what harnesses the energy from the sun, or harnesses the photons from the sun, and carbon acts as a semiconductor. So as the sun, photons from the sun, they hit the dye and they excite electrons. Electrons are what create electricity. Electricity is a net flow of electrons in one direction. So as these are excited, they begin to go through this circuit, through whatever machinery, like a light bulb, to illuminate it and make it function using electricity. But the fun part comes when it gets to this side. There is a redox reaction between the electrolyte solution and the carbon. So in the electrolyte solution, we want to transfer electrons over to the dye side, since as electrons are being hit and excited, they're flowing this way. So there needs to be more electrons on the dye side than on the carbon side, so that the whole circuit can continue. This is what the redox reaction accomplishes between iodide and triiodide. So that keeps it all going and functioning in a nice circuit. So how much power can this solar cell make? Well, two studies looked at this. One from a student at Cal Baptist and one from a team of scientists. They both used a 4 square centimeter solar cell, which is about the size of a silver dollar. They both got just over a half a volt of electricity from it, which is very good considering the size. So, looking at a single white LED light, it needs 3.5 volts to be able to be illuminated. Putting that into perspective, a paper-sized solar cell would be able to illuminate 24 based on the low number, or 29 based on the high number, LED lights. These are those little diodes in there. So it would be able to light up about 2 of these little lamps, and that would give a good amount of light, just the size of paper. So in looking into making the solar panel, we have to look at the costs. costs of solar panels in the United States are calculated based on the wattage. Now, we know about the voltage, but how do we get to the wattage? That's where amps come in. So an LED light needs or involves 0.26 amps. And calculating that, 29 LED lights, or 24, would amount to 21.6 or 26.8 watts. Our little paper-sized panel would cost, on the low end, $40, and on the higher end, $10, $100. So, depends on where you are, which state, since the costs vary per state, but it could be pretty cheap making these. Now, what can we do with that power, that electricity? We can provide light at night in mines for these people, and there is a bit of overlap between the people who have no access to electricity and people who have not been able to have the gospel shared with them, especially in this India region. So this creates an in for missionaries. If scientists or college students going on an ISP trip, they wanted to bring these solar panels over there, they could, because some governments don't like missionaries coming in, but if we say that we're going to benefit the inhabitants by bringing electricity, that they would give us the green flag. So that could create an in for providing light, electricity, as well as the light of the world, Jesus, to them. So, unfortunately, the solar cells cannot last forever. They are prone to breaking down and faltering because of UV radiation and extreme temperatures, which are both present in India as well as Africa. And this causes them to need some upkeep, which could be more expensive. But the same people who found that voltage for us that we use, they also found that adding magnesium iodide additives to the electrolyte solution provided some stability and made them last longer, which is good. So, in conclusion, sensitized solar cells can convert enough energy into power to be usable and feasible to be used on a bigger scale. They can provide electricity for these people who have no access to electricity, can improve their lives, and could open up doors for missionaries wanting to reach these people who don't have Jesus and don't have some of the luxuries that we have in the United States. So, in closing, we look to Ephesians 5:8 and consider how for at one time you were darkness, but now you are light in the Lord. Walk as children of light. So, if we can bring light, a clean, cost-efficient light to these people, that'd be amazing. So, yeah.